Hello, and welcome to this presentation. You see how to configure and test an OCFS2 cluster comprising 3 Oracle Linux 8 instances. Prior to the configuration activity demonstrated in this presentation, one of the instances was configured as an Iscsi target, and another was configured as an initiator. You can see that part of the configuration process in the presentation titled Configure a Linux Iscsi Target and Initiator on Oracle Cloud Infrastructure. The 2 cluster members used in this presentation are instances in the Oracle Cloud Infrastructure and shown in the illustration on this slide. The shared Iscsi storage is provided by a block volume attached to another instance which has been configured as the Iscsi target. The Iscsi connection from each initiator uses the target instance private IP address and locally configured target IQN. In the following demonstration, we apply a rule to the firewall for port 7777 and install OCFS2 tools to configure the cluster. After the cluster instance ports are set, from one of the cluster members, we create a partition on the shared storage device. Then we make the OCFS2 file system before mounting on each cluster member. The cluster status is checked, and then the shared storage is ready for access from each cluster member. Now, you see how to perform this configuration in the following demonstration. During the demonstration, most of the configuration activity takes place on the cluster member SMM Cluster 01. Because many of the configuration activities take place on both instances, I will explain when steps need to be repeated on cluster member SMM Cluster 02, but will not show the steps to save time. The Oracle Cloud Infrastructure Virtual Cloud Network Security List includes a rule to allow traffic for port 7777 from any source on the VCN. So the next step is to enable port 7777 on the 2 cluster members. I'm logged into the Oracle Linux 8 instance SMM Cluster 01. Here, set the firewall to allow communication on port 7777 for TCP and UDP protocols. Enter sudo firewall cmd --permanent --add port equal 7777/TCP --add port equal 7777/UDP. Reload the firewall rules with the command sudo firewall cmd --reload. Repeat these firewall commands on the other cluster member, instance SMM Cluster 02. Clear the screen and check the firewall settings by entering sudo firewall cmd --info zone equal public. The firewall command output confirms port 7777 has been enabled for the TCP and UDP protocols. Clear the screen. To install the software on an instance on this isolated VCN, we've configured an HTTP proxy on the bastion. So sudo -e is used to pass the proxy environment variables to the DNF command. Enter the command sudo -e dnf install OCFS2 *-y. The package name includes the wildcard star to shorten the typing and still ensure I get the relevant packages. After the command runs to completion, run the same command on the other cluster member instance, SMM Cluster 02, then return to this terminal. On SMM Cluster 01, create the cluster and add the members. Start with the command sudo o2cb add cluster OCI OCFS2. Then sudo o2cb add node OCI OCFS2 SMM Cluster 01 -IP 10.0.2.10 and sudo o2cb add node OCI OCFS2 SMM cluster O2 -IP 10.0.2.11. Clear the screen. Display the cluster configuration file with the command sudo cat /etc/ocfs2/cluster.conf. Copy the contents of the file into the paste buffer and switch to the terminal for the instance SMM cluster O2. Create the cluster configuration file on SMM cluster O2. First, create the directory with sudo makedir /etc/ocfs2. Then create the configuration file with sudo vi /etc/ocfs2/cluster.conf. Insert the contents of the paste buffer and save the file. Return to the instance SMM cluster O1. Initialize the cluster. Enter the command sudo sbin o2cb.init configure. Enter Y in response to the load O2CB driver on boot prompt, then accept the default values at each subsequent prompt by pressing return. Run the same command and provide the same response on the instance SMM cluster O2. Return to SMM cluster O1 and clear the screen. Check cluster status with the command sudo sbin o2cb.init status. Note that the cluster heartbeat is not active. On the instance SMM cluster O2, the cluster status also shows the cluster heartbeat is not active. On the instance SMM cluster O1, enter sudo systemctl enable o2cb. Recall the command and change it to sudo systemctl enable OCFS2. Clear the screen and perform the same commands on SMM cluster O2. Return to SMM cluster O1 to set some kernel parameters. Start by interactively setting them. Enter the command sudo sysctl kernel.panic = 30. Recall the command and change kernel.panic = 30 to kernel.panic on oops = 1. Now, to make the kernel parameter settings persistent, add the kernel configuration file by entering sudo vi /etc/sysctl.conf. Insert 2 lines into the file, kernel.panic = 30 and kernel.panic on oops = 1. Save the file on exit. Make the same kernel parameter settings and updates to the configuration file on the instance SMM cluster O2. Clear the screen. Now, time to create a partition on the device so it can be used. Enter sudo fdisk /dev/sdb. The block device in this configuration is being reused and the old ext2 signature can be removed. This only need be done from the instance SMM cluster O1. So enter the letter N for new partition. Press return at each prompt to accept default values to partition the entire space. When the 50 GB partition has been created, enter W to write the partition. Clear the screen. Now, make the OCFS2 file system on the partition. Enter sudo mkfs.ocfs2 -l. Inside quotes, enter OCFS2 /dev/sdb1. Clear the screen. Now, create a mount point on SMM cluster O1 for the volume, mount it, and check the status of the cluster with the next 3 commands. First, enter sudo mkdir /u01 to create the mount point. Next, enter sudo mount -l ocfs2 /u01 to mount the volume. Last, enter sudo /sbin/o2cb.init status to check on the cluster. Note that now there is storage for the file system to use, and the heartbeat is active. Perform the same 3 steps on the instance SMM-cluster02. Note that the heartbeat is active on this cluster member as well. Return to the instance SMM-cluster01. Now, test the cluster file system. Clear the screen. First, copy some files into /u01. Enter sudo cp/boot/vmlinuz to /u01. Now enter ls/u01 to see that the files are there. Create a test file by entering sudo vi/u01/test.txt and input the line, "This is written from SMM-cluster01." Then save the file. Verify the file by entering cat/u01/test.txt and see the line that was input. On the instance SMM-cluster02, clear the screen and enter ls/u01 and see that all the files are present. Update the test.txt file by entering sudo vi/u01/test.txt. Then provide a second line, "Update from SMM-cluster02." Save the file. Return to SMM-cluster01 and recall the cat command to display /u01/test.txt. The 2 input lines are displayed, showing that the file is shared for read-write access from both cluster members. For additional Linux learning opportunities, visit the Oracle Linux Learning Library at www.oracle.com/go/to/Linux Learning Library. Training for the Oracle Linux Cloud Native environment provides presentations on cloud-native technologies. See www.oracle.com/go/to/Linux Cloud Native Learning, and see the home for all of Oracle Cloud Infrastructure documentation at cloud.oracle.com. This ends the presentation. Thank you for watching.